Redox reactions. A 0.376 gram sample of iron ore is dissolved in acid to reduce the iron to iron 2+. This acidic solution of iron 2+ is then titrated with 41.25 milliliters of 0.02140 molar potassium permanganate. Determine the mass percent of iron in the iron ore. So we want to know grams of iron 2+ over grams of iron ore times 100. Well, I have my grams of iron ore, but I don't have my mass of this. I am, however, given information of my potassium permanganate. So I know that I can always go from one to another using mole ratio, which means I have to balance my reaction. Now, a couple things. In this reaction written here, there's no K. But if you look at potassium permanganate by itself, since it's a 1-to-1 ratio, potassium here is a spectator ion, and we know that the same information can go just for permanganate. Alright, well, with that said, I need to isolate for iron, but I have to balance. Now, it says unbalanced in acidic solution, and before even looking at that and trying it out, well, iron and iron, permanganate, manganese and manganese, oxygen and no oxygen, so that's not going to work. So we first have to balance this redox reaction. The way that you do that is you split everything up into a half reaction. So if I just take my iron 2+ to my iron 3+, what's happening? From 2 to 3, I became more positive, so I lost an electron. Iron and iron, there's both one of them, so that's balanced now. Then I look at my permanganate. MnO4- goes to Mn2+. Well, let's first figure out what is the oxidation number of manganese in permanganate. I know oxygen is always -2. There's a charge, so the whole thing has to sum to -1. If I have 4 oxygens, that means I have -8. If the whole thing has to equal to -1, manganese is going to be +7. So I go from +7 to +2. I went down in numbers, so permanganate gained 5 electrons here. Alrighty, well, there's still the issue of you have 1 manganese and 1 manganese, but you have oxygens on your left and not on your right. So to balance that, we add water since it's an acidic solution. I have 4 oxygens, so I'm going to add 4, I'll do it here, 4 water molecules. Perfect. Manganese is balanced. I have 4 oxygens. They're balanced on both sides. But I created another issue. Now I don't have hydrogens on my left side. So you have to add hydrogen ions. Well, I have 2 times 4, that's 8. So then I add 8 hydrogen ions here. Perfect. Now I sum everything up. However, before you do that, we don't show electrons in a final reaction. Everything should be balanced. So we have to cancel out the electrons. So I have 1 electron on my right side for my first half reaction and 5 on my left side for my second. So to balance that out, I'm going to multiply the first reaction by 5. This will give me 5 iron 2+, 5 iron 3, and 5 electrons. Then if I sum the whole thing together, I will get 8 hydrogen ions plus 5 iron ions plus permanganate. 5 electrons cancel out, goes to 5 iron 3+ plus 4 H2O and 1 manganese 2+. Now I am completely balanced and I can see the relationship between permanganate and iron 2+. Now I want to solve for my mass of iron. Well, I know that I have 0.25 milliliters and 0.02140 molarity of permanganate. Well, I can use that to get moles and then use my mole ratio and molar mass to get my answer. So I start with my volume in liters times my molarity. Then you can already see, okay, my liters are going away. Now, since I'm in permanganate, I can use my mole ratio, which is 5:1. Then my moles of that go away. And now I'm in iron 2+. Since I want mass, I have one more step, and I use the molar mass. And that is my grams of my moles of iron 2+ cancel, and I'm left with my mass. Now, if I go back to the question, it says, determine the mass percent of iron in the iron ore. So I already wrote myself my little equation up here, so then I take my 0.246 grams of my iron 2+, divided by my overall mass, 0.376 grams, multiply it by 100, and I get 65.6%. Whoops. So here, you were given the information of one reactant, the molarity and volume. Whenever you have molarity and volume, because molarity is mole over liter, you can always cancel out the liters and get moles. We've learned that going from one reactant to another, one product to another, or a reactant to a product, we use the relationships they have in a reaction they are in together. That is all in moles. So that means you have to go to moles. So if you have a volume and a molarity, you can go to moles. Well, you have to be balanced. Most of the time, we just add the numbers and balance the equation. In this scenario, though, not only were the electrons not balanced, the oxygens were also not balanced. Now, I want to add, if the oxygen wasn't in this equation, you would have still had to make two half equations and balance out the electrons like we did. We wrote, figured out what was lost, what was gained, and multiplied and manipulated the equation so that the electrons cancel and they're balanced. In this case, we had oxygen in the permanganate that didn't show up anywhere else. So we had to add water and hydrogen ions to balance out all of the elements. Then when your reaction is completely balanced, you can use all the tools from the stoichiometric relationship to get to your final answer. Now, this whole problem could have been done if we were looking for molarity in the end and given another volume. Mass, atoms, etc. Those are all extra steps, knowing you usually always have to do mole ratio.